Hi everyone, welcome to this workshop on template injection. My name is Philippe Artaud. Today I'm going to present a workshop that was given at Hackfest 2020. It's about the exploitation of server-side template injection. So in this workshop you'll gain knowledge and skills to exploit this type of vulnerability. You should be able to test this potential vulnerability in real-life application after this workshop. In this workshop, we're going to cover different template engine in different language. So this way you'll get also great knowledge to be able to identify in an application which template is being used potentially. And all the applications are no longer available online, but you should be able to download the source code and build the Docker image yourself by cloning the repository of the workshop on Go Secure repository. So all exercises that will be presented today will be available on this repo, and they are all Dockerized application. So without further ado, let's start with the content of this workshop. So template injection, we're going to exploit templates engine that were not necessarily intended to be exposed externally. So template engine were mainly initially used for static view. So in a template you'll get some static data, but in the template you'll get some elements that are dynamic. So dynamic values are replaced in the template by it could be a complex object, but also just string, int, any type of values can be bind is in this template. So template would look like this. So if I have a template for an email or a view of my website, it would look like this. So hello will be static. I will have, for example, the variable first name and then a variable last name. The thing with templates is that while they might be mainly used for static view, sometimes website will expose those templates, so a remote user can send these template or at least a section of the template, maybe only. So, and by having a control over a portion or a complete template, the user will be able to trigger interesting feature. So while we might be able to access variables that are directly bind to the templates, template engine are being a complex, are kind of a complex component, and we can kind of relate to those as a scripting engine because they will have loops. You'll sometimes be able to call utility method, sometimes you'll be able to instantiate classes from your application. So with this type of feature, we'll be able, at least today in all 6 exercises, to gain remote code execution by only feature from a template. So we're not going to look at corruption, heap corruption, or stack corruption. Only using the feature, we'll be able to escape the intended use case of those templates to gain remote code execution. One of the things with the exploitation of template engine is that when you are doing black box tests, you might not know in advance what will be the template engine. So unless you are doing a code review, let's say with a static analyzer or a manual review, you won't know ahead what is exactly the template, because even by having a good idea of the language where the application is running, you'll still have plenty of options to look for per language. This is a decision tree that is taken from James Kettle presentation from 2016 on template injection. So the presentation from James Kettle was an excellent introduction because it covered multiple templates engine, and a technique he proposed for identifying template engine is doing these type of binary tests where you test a payload that has the potential to work for multiple templates engine, and from this you can go along in the decision tree and find which templates is being used. So this decision tree apply if you want to identify mainly PHP or Python templates. By doing simple arithmetic with maybe 2 or 3 payload, you'll be able to confirm what is the template being used remotely. I'm now going to present the main content of this workshop, which is the exercise. Each exercise are independent, so you feel free to jump to the exercise that you want to prefer. So if you want to do right away Python exercise, you can jump to lab 2. You can do them in the order that you want. We have marked in the video each section, so you can easily jump to each section. I'm not doing pause for letting you time to reproduce yourself the exercise. So when you have heard the instruction, make sure to do pause, reproduce the demonstration I'm doing, and then you can continue to the next exercise. So we're now going to do the first exercise of this workshop. This exercise will be using the Twig template engine. It's an engine that is working on the PHP language. It's being used, for example, with Craft CMS, CMS that was found vulnerable to template injection. The basic syntax of Twig will be variable being bind with double brackets, then a variable name, and optionally you can specify filters that will transform those string or values. And what James Kettle found is in his research in 2016 is that he found that first self is exposing some Twig API, and one of the interesting API is register undefined filter callback, and it's the objective of this function is to register a function that will receive filter that have no callback yet defined. So basically filter that are not handled. So instead of, let's say, using escape, if I'm using a string that is not associated with a valid filter, this callback will receive the name of the filter as a parameter. And what we're doing here is we're registering the function exec. So in PHP, exec will execute a command and will return the result of the command being executed as a string. So this function will receive filter name when they are not found. And the next thing we're doing is with the Twig function get filters, we're going to trigger the filter ID, which doesn't exist, and with this it will pass effectively this string ID as a parameter to the function exec. So on Linux, ID will display the current user. So this is currently the payload to exploit Twig templates, and that's what you're going to be able to do in this workshop exercise. So we're now going to do the exercise for Twig, and in this exercise we're going to see the type of payload for Twig, but also I want to put an emphasis that you should always do a small arithmetic test or a small test to confirm that there's an actual template that is being executed on the server side. And for this one, it's pretty easy. It's only one input, but obviously in more complex application you'll have tons of form with multiple input that are not limited to obviously field. But here in this simple exercise, I'm gonna do 1338 minus 1, and what I want to see is, will it return as is with the brackets, or will it evaluate, and are we going to see the subtraction result? And here we can see that actually the subtraction was applied, so most likely there's a template evaluation being done remotely. We're also going to confirm in BERT that the payload that we've sent, I'm going to look at it. Okay, so now we have the payload in decoded form, and we're going to confirm that in the response, I'm going to zoom here, that the actual value is 1337. So the reason I want to see it in the HTTP response is that while it might be shown in the browser, this doesn't mean that this was rendered on the server side, because there are, for example, AngularJS that will render templates that are also between two brackets like this. So you might have some excesses with AngularJS, but for today we're focusing on server-side template injection. So now we have a confirmation that template is being executed. So I'm going to copy the payload that we saw in the tutorial for the lab 1, and right away I can see that in the response, so I'm gonna switch to BERT just because it's a better practice to send your payload in a proxy. First, you're gonna get visibility for all the payload, but also we're going to see in later exercise that sometimes the response is not directly in HTML, so it will be easier to do your test like this. So ID will return the result here, so I can see that this is the return value from the ID command. So the current user executing the application is www.data. If we are doing other command, I'm going to see that there's a small limitation. So here it's showing var while I'm listing potentially the content from the root directory. And we should expect that obviously on Linux file system there will be more than one directory at the root. And what is happening is that Twig filter are only showing the last line from the result of the command. So a way to circumvent this could be to do a reverse shell. So you could have a listener with Metasploit or just Netcat and connect a shell to this connection and have remote interactivity. So you don't need actual response in the page. One quick alternative, if you just want to do the exercise here and get the result efficiently, quickly, without deploying anything, you can, I'm going to put everything on one line, you can use the command echo-e, and what it will do is simply strip new lines and everything will be displayed online. So this way we'll be able to navigate on the file system and get the flag for this simple exercise. So if I'm doing the same command, ls/, I'm going to send this request, and we can see here the result. We're seeing all directory from the root directory. There's no more a new line, but it's good enough to get what we want. So here I can display the content of this mysterious secret directory, and once I'm submitting this content, I'm just going to jump always to the thanks message. You can see that there's only one file in this directory, and if you want to see the content here, I'm going to do a simple cat command like this. So if you're taking the payload from the tutorial, the Code Labs page, you can just replace the ID command from the payload with this, and this should be enough to basically see the content of any file on the server. So here we can see that we're able to read file remotely. So this was exercise 1. So take your time to play a bit with the two payloads. Also, you can also maybe do some additional tests if you want to dig into the other alternative with the syntax with Twig. But this payload is known to almost universally will work with Twig. For the second lab exercise, we're looking at an Jinja library. This is a library in Python. The syntax looks like the Django templates. So if you have seen Django templates or have played with Django at all, you should recognize the syntax that look also very well to Twig templates. So basic syntax for Jinja template, it will be also two brackets that are open, then you specify a variable name. You'll be able to access attribute using dot or I would say square bracket like this. This will be equivalent to equivalent way to access the attribute bar on the object foo. And variable that are accessible are any variable that are bind to the templates. But here we're going to see that in Jinja we can also specify a literal value inside of those tags. So the way Jinja exploitation works is we're going to try to access specific types that are in Python runtime. So, and with those types, we're going to, for example, access process open or the file type. And depending on the type, we'll be able to do different actions. For example, with the file type, we'll be able potentially to read a file. With process open, execute commands, we'll do pretty much anything on the system. And the way we're going to access additional types that are not exposed through a variable bind with this template is we're going to take any variable, and actually in the payload that I'm going to use, we're going to use just a literal string, which is equivalent of using any variable name that could be accessible to this template. The reason why people use empty string in their payload is that this way we know that for sure it will work in any context. Meaning if I have a variable being called message in the template that I'm sending, in another template it might be user or any other variable name. So here, by creating a literal, which is basically creating a variable on the fly, we're sure that it will exist. So this way there's less modification needed to the payload. So first thing, Jinja is giving us access to the metadata property underscore class. This is a meta property that is part of Python language, and in the class definition of the object string, and actually in any class definition of any object, we're going to see also a meta property called method resolution order. And this is describing the type hierarchy of the object we have selected. So here empty string is of type str or string, and string is extending base string, and base string, like any object, in the end will inherit from the type object. And once we have this hierarchy, we can see that we can go up to parent types. We're going to do the opposite trajectory. So we're going to start from object type, and we're going to try to see all the objects that are subclasses of object, so meaning every type in Python. So we can do this by going for the third or the index 2. So index 2 is the third element, so that's type object. So this value is effectively the type object. From this type object, we can obtain all the subclasses, and this will give us, if we evaluate this at runtime, a long list of type, because every type in Python that is accessible to your application will be displayed. Now from this list of subtype, we can select an index, and this will give us any type that is not just a basic string, or any type that could be the type of the variable that we can bind. So any type that will be list, we can access them directly. So one example, that this example is really simple, but will only work in Python 2.7. The index 40 on Python 2.7, it will be the reference to the type file, and since this is a reference to the file type, we can call directly the constructor by giving two arguments, the file name and then the attribute for the file access. So here it's in a read mode. This will return us a file handle that, and this file instance, we can call the method read, and all the file content will be returned as a string, and in the end shown in this template. So our long chain to gain access to object and then get access to another type, in this case file, is equivalent to the Python code file with etc password read. So now we're going to look at a more powerful type. Process open will execute a command. So popen stands for process open. It's a class from the namespace subprocess, and depending on the version of Python, the index of this subclass will be different. So from my test, when I've run an application on the same version of Python, so let's say Python 3.8, even if you restart the application, index will usually be the same. So that's why I'm including in the reference 396. And this will work in Python 3. In Python 2.7, this is a different value, so you need to be aware, but in the end, it will be the same type. Okay, so now that we have access, we have a reference to the type popen, we can instantiate a process open with the command ls with few arguments that are mandatory for this API, and then communicate will execute the command and recuperate the result in the form of a string, and strip is just to remove some new line at the end potentially, and this will execute arbitrary command. So I've included another payload alternatively that is will only work in 2.7, so less likely to happen in modern application. But this one is interesting because it's taking another route to access various types that might not have been loaded into the Python runtime. So you could have some modules that are not loaded because they are not being used. And in Python, you need to import classes before they are being loaded into your runtime. So here we're also going to get a reference to the type object, but here we're gonna go to the subclass with index 59, and this is a warning, a catch warning type, and this is including a cache of various modules that could be loaded. And from this, we're going to be able, by accessing a cache inside the warning instance, we're going to be able to access the OS module. And OS module has the function system, which will execute a command also. System will not return as string the result from the command, but you can easily just output the content to a temp directory if you have at least one directory when you have write access, and temp directory is usually one. And then from a second payload, starting with two brackets, you can now read again this file, so combining two payloads. So this is a more complex payload and will not work in Python 3. The reason I wanted to show this payload to you is that it's often used in Sandbox escape challenges, sometimes in CTF. This is something that can be used in other contexts than template injection, and it was just to show you also alternative. Now we're going to see how to exploit this with this simple application. So here is the simple application for Jinja 2. Here we have multiple fields. So all these fields might not be evaluating templates. So to test these, I'm going to do a simple subtraction, but here I'm going to try to do different values. So this way, depending on what we see as being evaluated, we'll know which input is being included in a template. So if I click create, this is exporting a vcard format. So unless you want to download each time the file, I encourage you to use again burp. So here I'm going to check the request that we just sent, and I'm going to send it in repeater just to work easily with the different inputs. So here we can see that there's multiple numeric values, so doing subtraction with small number is probably not the best option. So I'm going to include different values. So I'm going to do just 1000, 1001, 1002, 1003, and then sending it again. Okay, we're going to look at the output. So now we can see that first we can see that the first field, the name, is being displayed. So the first one, name, is supposed to give 1000, so we can see that is being even displayed multiple times. We can see that the organization is placed here. I know here because it's 1002 but -1, so 1001. We can see that also the phone is placed here in the field telephone for work, and finally email is placed here. So all fields are actually evaluated. So what we can do is only take a value, for example organization, that is evaluated once. We can send this to repeater. So which field did we choose? Okay, we're gonna go with organization. And I'm gonna pick payload that is known to work on both Python 2 and Python 3. So I'm gonna first start with this and see if I can already skip some steps. So here it's displaying nothing, so most likely that this type doesn't exist, or it has less than 300. So one thing you can do is evaluate it without an index, like this, subclasses. So this will return us the complete list of subclasses of the object type. So as you can see, there's a long list. So You can copy paste this in a file editor, the editor of your choice, and sort them, not sort them, but align them, so one element per line. And if you look, for example, for process open, popen, here we can see that this type is available. So because this is a Python 2 application, it's going to be 245, but you can always confirm by doing this manually and extracting the index for this one. So don't count them, just open this in a text editor, split every comma with a new line, and this way you'll be able to jump to the right line and get the index. So if I send this, I can see that I get the type process open. So now we can continue with the rest of our payload. So this will be the argument for it. So just after accessing the type, the only thing I'll need to replace is the command here. So I'll need to do a couple of execution to get what I want. So again, we can see that we get a listing of the root directory from this server, or this container, I should say. Then I can go into the secret directory again, so similar as the previous exercise, and here flag jinja.txt, and we should be able also to read the content with the command cat. So now we have all the file content here. So this was the another simple exercise with a different template engine. For this next lab exercise, we're going to look at a different template engine also in Python. So Tornado is a web framework to deploy simple web application, and it has its own template engine built into the framework. And users have the capability to expose those templates potentially. So the thing I want to show with this template is that some template engines are much more easier to exploit, and with this one we don't need to do a complex chain to get access to the OS module or the class popen. Here we can see that we can do import with the syntax itself. So for the payload for this exercise, this will be really quick. All you need to do is first get a confirmation that you have a template being injected, but by copy pasting this will execute command as is. So you can connect again to this exercise to do it yourself. Here I am in the test application for Tornado. So I'm going to do something very similar to the previous exercise. So I have multiple fields. I'll send different payload just to see what is our injection point. And here, this is a pretty basic application, to say the less. And here it's simulating that you'll get an email, but instead of having an application that will actually send an SMTP request to your mail provider, I'm just displaying what would be sent as an email. So here we can see that the name that you've entered is part of a template, and it's being concatenated to the template of the template email. So you don't have access to the complete email, but that you don't have access to the complete template of this email, but part of it which is evaluated, so it's not properly bind. So some value might be bind and some are just concatenated, and it's through those concatenated value that we'll be able to inject template injection. So in our proxy, we're going to jump to the faulty form, and our injection point is the name. So what I will do is here, this is the field that is doing the subtraction. I'm going to replace this with our payload, and as simple as this, if I send this parameter, I can see that just after the hello, I get the result for the who am I command. So this Docker container seems to be running as root, and you can continue by doing some simple command here. I'm accessing the root of the file system and directly having access to a file just to confirm that I manage to get remote code execution. So here I need to replace ls by cat, and I've got the flag here. So again, another simple exercise. So you can also do a test as you want. This is running with the Tornado template. For the last few exercises, we're going to switch to the Java language. So it will be first Velocity template engine, and then Freemarker. So without further ado, the syntax is a bit different for Velocity and Freemarker. Variable will be bind this way, so there's no bracket, double bracket. Variable would start with $, kind of similar to variable in the PHP language itself. So, but this is not PHP. This is the Velocity template that will evaluate those. We also have the capability to assign variable. So here I can assign on the fly, create the variable foo and assign the value bar, and it's being displayed here. So this hash set will assign a variable to in our template. The first payload that was found by James Kettle used the class tool plugin, which is optional, so it's not in every environment that you will see this, and I think it's in Struts 2 with the Velocity support. There's one framework that has Velocity integration that will add this class tool plugin enabled by default, but that's not the payload that we're going to use for today. Today we're going to use a bigger payload that is, however, working on any Velocity template engine that doesn't have any type of sandbox. So this payload will look up the runtime classes and will display the content of an execution. So just to show you the payload step by step. So first we're assigning an empty string to the variable x. That's again purely to be sure that there's a variable name in our payload, so this way we can copy paste this payload without having to look for which variable is available in my template. So you can replace x with any variable available in the template, but here it's just simpler to assign this. First we're gonna access the property class, which is a property that exists for every object in Java. This will be a class definition, but it also has some static method. In here with the forName function, we're going to be able to load different type. So this instruction here will load the runtime classes in the variable runtime, or RT. Same thing here for the class character and string. Those two types will be needed to display the result of the command. So basically, once we have the class, the type accessible, we can call any static method of our type that we have accessed. So here from the runtime class, I'm going to call the static get runtime, which will return a new instance of runtime, and the class runtime has the function exec, which will execute a command. So it will execute command on the system. Now the next 3 lines are purely loops that will display the result. The input get input stream is the command's output. So this way we can in the template get already a result. Obviously you can replace this. You don't necessarily need to do this if you are doing a reverse shell and you're connecting to a netcat or a Metasploit listener. But this is the payload that we'll use in this simple application. So one thing to remember for this application, it's password protected. The only idea I had in mind with this is just to show you that in general, those features of having access to editing templates, this is not something that guest user will have access to, but often limited administrative user might have access to this if they are able to edit localization from the web application. They might be able to edit some templates. So here we're just having a small scenario where you have compromised one user from the application that doesn't have access to everything, but based on this user you'll have complete access to the system. So you can connect to this application. You'll be able to log in with admin password 123456. So I'm now inside the test application for the lab for velocity. So first thing I need to do is access this admin functionality. So I'm logging in with the given password, and here I can see that I'm able to edit email templates. So I'm kind of an administrator, so I can edit any templates. What you can do is either remove all the content if you want, or just prepend and keep the original payload. One thing to remember, if you're multiple using the same environment, you won't step on each other's foot. All the templates that you're editing are not stored permanently on a database. These are isolated for each session. So every user, as soon as you get a new cookie, you have your own set of 2 templates. So even though they are named the same, you're not affecting other users of the same application. So this is just a dummy application. If I'm testing, so let's say I've done some tests just to confirm that this is a template, a velocity template. I'll do a simple instruction that assign 1, 2, 3 and then display the value. I can see that as a result it works because it's displaying 1, 2, 3 and it's able to evaluate a set like this. So what I'm going to do next is go right away for our big payload. I'm going to execute the command ls here, and this is the chain that we just explained you. So if I do test, now I can see that I get complete listing of the root directory. Then again, I only need to change the command section of my payload. Then there's right away a flag. And if you want, you can experiment obviously with payloads. With file read access, you'll be able to access multiple proc special files, be able to potentially see process open, different resource from the environment. So if you want to play with it, you can do it. And that's it. So this was as simple as this. So this payload is almost universal with velocity because it doesn't require any optional plugin like the class tool one. We're now in the Freemarker section. So this is another template engine for Java. The first exercise, the lab 5, will be the vanilla payload with no sandbox in place, but then we're going to see a realistic scenario with sandbox in place and see how it can be bypassed. So Freemarker syntax will be $sign followed by a single bracket, then a variable name, and closed by another bracket. Freemarker has kind of a unique constraint. You won't be able to easily call any method or any field on your variable. It has what are called built-in, so kind of like the filter from Twig. You'll be able to add a suffix to your variable to call built-in function. So these are simply called in the documentation built-ins. And this is an exhaustive list of all the built-in available in Freemarker. And these are specifically designed by Freemarker, so you cannot call any property or function from Java. The way we're going to be able to call arbitrary method is through assign statement. And one interesting built-in is the new built-ins, and with this we can instantiate any classes that is a subclass of template model. And even in the documentation we can see that there's a warning like this. This built-in can have security implication. You can read the complete warning on the Freemarker documentation. And this is what James Kettle has used in his 2016 presentation. So because it's limited to a template model, we can look at all the template model classes in the Freemarker library, and one of those is the execute class. And it's unless there wasn't this class, it would have been much more complicated, but here we can simply apply the built-in new to this string, and it will instantiate this type. As a result, the template model will be initialized to this variable exec. And when we can now use this template model directly, and we will call its main method. So all template model implement the same, I think it's exec method. And here we can execute the command ID, because this is the implementation of the execute class by the Freemarker library is to execute command. So potentially that the use case they were looking for is that often templates are used for documentation, and if you want to have a common result in your documentation, then you can simply inline some result in your template. The thing is, if you're exposing templates to your user over web application, this is a really different test case, then this can be problematic. And that's what we're going to see in this final application, which will be using Freemarker this time. So a very similar application to the Velocity one, but with Freemarker. I am now in the Easy CMS application, the application for the Freemarker exercise. This is the un-sandbox version. We're going to see later the version with one sandbox. So if we log to the admin panel, for this application the password is ACFest. So admin ACFest, you'll find all instruction in the code labs. If we exit one payload, we're going to see that here in the template we have example with the $sign and a bracket. This is a huge hint about what potential technology is being used, so I'm going to be opportunistic and assume that this is a Freemarker template. Here, when I'm going to send this payload here, so obviously this application was made to display right away the result. So here it's we can already have a confirmation that the command ID has executed. But in real life, sometimes you have to upload templates. Maybe there's a functionality to import file that could be templates. But sometimes you'll need an additional request to trigger them. So that's something to keep in mind. Here, it's made easier for testing because it's just a workshop. But keep this in mind. So what else can we do? We can do the same thing as previously. So if we execute command ls in the secret directory, we can see there's also again flag.txt, and we can grab the content here just like this. So it's same principle as the velocity template. You just need to replace the command here each time you test your payload. So that was it. This was the basic payload for Freemarker that was initially released in 2016. We are now at the last exercise of this workshop, and for this lab exercise we're going to look at an application with Freemarker, but with a small twist. Sandbox is being applied to the templates. So a Sandbox will be a mechanism that will limit the functionality and classes that can be accessed inside of a template. The way it can be implemented in Freemarker is with the use of the class template class resolver. This class will control which class can be referenced inside of the template. So for example, when we were using the built-in new with a class name and parameter, this will go through a template class resolver. However, it's not filtering which class will be loaded. So for example, I can use an utility class that is allowed and that is accessing another class that could be a blacklist. So it's only looking at the reference inside of the template, but it's not kind of a class loader filtering. We're going to use a technique that was presented at a talk this year called Room for Escape. So this was presented at DEF CON and Black Hat. You can have access to the video from DEF CON on YouTube, and a paper is available online also. So what they found multiple techniques to escape Sandbox that could be done, for example, with Freemarker. And the example they gave are all using existing variables that are bind to your templates. And these technique will not work with when it's purely scalar, like string being bind to the templates. You need at least one object being bind to the template in order to work. So the first thing you'll need to do is look at what is available to the templates. So in a newer version, you need to use the list directive to enumerate all the keys from data model. So data model include a few things from that are internal to Freemarker templates. This is an alternative for older version. And once we'll have a reference to an object, we're gonna try based on the type that is because for every variable we're gonna be able to access which type are those variables. We're gonna look for a chain to access a class loader. So class loader in Java is responsible for loading class, and with those classes, then we can instantiate objects that have interesting functionality, like execute command, read file, etc. etc. So class loader can be loaded from multiple locations. So by default, every object will have a property class, and from this class object we'll be able to access the class loader. But there are a few alternatives to get the class loader for the current thread. So for example, here for the current thread, there's through the protected domain class. So these are a few alternatives to get access to a class loader. Once we'll get access to a class loader, we'll be able to apply the chain that we want to load, for example, the execute class from Freemarker and then execute command. So one thing that we cannot do is take a reference to an object and do .class loader. This will not be possible because class is blocked. So we'll need to find alternative like those one. So for example, if we have a reference to the request object, we can look at its property servlet context. This .servlet context is equivalent to calling get servlet context on the servlet request object, and then class loader is equivalent to get class loader on the servlet context. Okay, so one of example, once you have a class loader being loaded, so you need to first find a reference to a type that is not a string, and from this type you need to find interesting path to access class loader. Once you have something access to class loader, you can follow it by this payload. This payload here is resolving a URL. So here it's a local file, and it's opening a connection to this file to extract its content. So all this is starting from the class loader reference, and we're loading a file from this. This is pretty primitive. We're only looking at files so far. I had difficulty to reproduce this payload taken from the paper. It seems like byte array couldn't be printed directly. So Freemarker in the recent version were not printing bytes. It was just giving an error here. It seems to mandate string or scalar to be print, or something that has a toString. An alternative way would be to iterate over each byte one by one to get the file content. This is harder to get, but there is obviously an easier payload. There's a universal method. So in their paper about the Sandbox escape, they present multiple methods that are specific to containers. So because different web container will have a different implementation for class loader, so not the same function will be available, but they found a technique that will work on all of them, and this technique is the following. So we're gonna need as a requirement an object that is not a string, and from this, because I mentioned class loader on the object class is blocked, but get classes is not blocked, but get class loader on the object on the class on the type class is blocked. So but we can access to protected domain which has access to a class loader. So from this, once we have a class loader reference, so this we can print it. Freemarker will have access to the toString method and will display it, so you can confirm that this is load, and then you can follow your payload with this, which will load, which will basically override a setting on Freemarker and allow you to load the execute classes which was blacklisted. So because we're using a class loader to load this class, this is not the same as using the built-in new, which would initiate the class and go through the filtering classes that I mentioned, the class resolver. But with this final call to the class loader, we're not passing through the filtering mechanism. And because there's no class loader filtering, we can load arbitrary classes at this point. With the execute classes, we're going to instantiate it with new instance. So this is like calling it by reflection. And then once it's instantiated, we can call the exec method from our template model, execute. During the workshop at Hackfest, a couple of people had trouble with this payload, which was a minor, and it was always for two people it was the same mistake. They didn't replace this part. They used the payload as is with object, but this you need to replace it with a key that you have found, which is a variable that is not of type string. And I've come up with a small payload that is just a small variation, but still using the same universal payload. What will it do is it will iterate over the data model with all the variable available, and it will test for each variable. Can I apply this chain? So can I access class on this object? And if it does, then all those 4 lines will work effectively. And at the end of it, it will execute your command. So this is kind of a brute force method to just copy paste a template if you have a Freemarker that is under certain Sandbox. So the thing is that if you have multiple, let's say 10 variables are available in your template that are not string, you will execute 10 times the command. So it's not ideal. The thing I've done is just place the payload in a temp directive. This is kind of a try catch in Freemarker. So this way, for keys that will be string, usually it's raising an exception when you call this. It will just show fail for each keys, and for the right variable, it will show you the command. So if you want to test this universal payload on a Freemarker, you can go to the exercise, the last exercise. It's the exact same application as the previous one, but with this class resolver mechanism in place. So you won't be able to just copy the one-liner from the previous exercise. You can test it to see what type of error are being returned when there's a sandbox in place. Here is the last application. So this is Freemarker with a sandbox. I'm going to log in to the application. And the first test I'm going to do is, since I know it's already Freemarker, I'm going to test the payload from the previous exercise, just to see what it does. And here we can see that this payload was blocked, and the execute classes is not allowed. So this is because of the class resolver, which is doing a filter around every class that is passed through the new built-in. So the new question mark new. Oops, I'm going to show you here. Every class that is being passed to this built-in will pass through this resolver. Now we're going to test the bypass that we saw previously. So first we need to identify a class that is not a string in order to use our universal payload that is here. But first we're going to identify the variable. So I know I presented a payload that will brute force automatically which class is working, but here I'm going to do it manually just to show you. So here I have 4 variables available, and if I'm evaluating each of those, I'll see that the first 3 are a string, and the last one is in practice this request wrapper from so security context holder aware request wrapper. This is a class from the Spring framework that is basically additional functionality on top of HTTP servlet requests. So it's still maintaining the same method from HTTP servlet requests, but with additional functionality. And as we saw, from HTTP servlet requests, we can access protected domain. From protected domain, we'll be able to access to a class loader, and then with a class loader, we can apply our chain. So here I'm going to copy the payload, the universal payload here. And the only thing I need to replace is the object here, this kind of value. So you replace it with the object that you found, and this should work. So I'm going to send it, and we can see that it's working. So we have command execution, and I'll go straight to the flag just to prove that it's working. Oops. So we can see that all file content is being displayed, and we can do anything on the server at this point under the user root. So this server or this container is almost fully compromised. So this was the last exercise of this workshop. So this is the end of this workshop on template injection. I hope you liked it and you learned a few things. The different exercises will remain on GitHub, but you need to obviously deploy them by yourself. Instruction is also on the repository. Feel free to ask questions if you have trouble deploying them. Here are some references to the different papers. So if you are doing some tests and you need some additional detail on specific template, I highly recommend you to consult those references. If you want to play with different technology and you want more template injection, there's actually Postgre, which is doing it's a web academy, so it's an online workshop similar to this one. They have 1 or 2 exercises that are not overlapping this current workshop. So if you want to play with template in Ruby, they have 1 exercise, I think, and another one also. So if you want to play with different technology, again different than the Python template that I present today and PHP, you will find some additional exercise. So thank you for participating in this workshop.